Hello everybody, welcome to our physics lessons. This section is 4.4, Forces Applied to Automotive Technology. In this lesson, we're going to talk about tires, brakes, ABS system, ESC system, crash testing, seat belt, and airbags. When we talk about friction, we saw that friction was about imperfection of the surface in contact. For many pairs of materials, the force of static friction or kinetic friction acting on an object is not affected by amount of surface area in contact with the surface. Instead, the coefficient of friction depends on a type of materials in contact. That's why we have a table of data with a coefficient of static friction, coefficient of kinetic friction, and coefficient of rolling friction values. So we can use that depend on material that we are studying the friction. However, rubber is an exception. So that's why we use rubber for car tires. The magnitude of static friction acting on a rubber tire on a road surface depends on the surface area of the tire that is in contact with the road. That's why in a race car, the manufacturers use wide tires without treads to increase the surface area with the ground. However, there is a downside for this. In a wet or icy surface, that friction decreases drastically. That's why racing is not allowed in icy surface or in a wet surface. In a wet surface, it's very dangerous. So that's the performance of those race cars will decrease drastically. The purpose of designing those tires of the racing car is to have the maximum performance, maximum speed. However, if the road conditions are not good, yes, we can cancel the race. However, you cannot cancel the moving of any vehicles because it's going to rain almost all the time. It's going to snow almost all winter. So we cannot really stop cars from traveling, from moving. We cannot really cancel a trip to work, to doctor, to anywhere because of the weather conditions. So that's why tires of the passenger vehicles need to provide a good traction, so force of friction, on a road surface under all weather conditions. The tread area of the tires has a small and large grooves. Grooves provide a pathway for water, such as rain and snow. Imagine in a slushy snow days when the car has to go through that weather conditions. So the water has to pass through those grooves in order to avoid accumulating in the front of a tire, and we're going to talk about that later. The tread of the tire is designed to work under various road conditions and to make safe and strong. There are many layers added on that tire. Driving on wet pavement sometimes becomes very dangerous. So the tread depth on a passenger car, new tires, is usually 7 to 8 millimeter. As the tires wear out, then the tread depth decreases. So that means that less water will come through grooves. So when driving at a low speed, then the water has time to move through grooves in a tire's tread. And when those treads are worn out, that means that becomes a problem. However, even in a new tires, if the car in a wet condition will speed up, water will not have enough time to go through those grooves. So that's why the water will accumulate in front of the tire. As the water will accumulate in front of the tire will go in from a normal to a transition. That is there's a water on both sides of the tire to a hydroplane when the tire and entire car is almost floating, hydroplaning. So that is dangerous because tire will lose the contact with pavement, with a road. So when you try to stop or to speed up, then there's nothing actually to grab. Remember, third Newton law, you have to push the ground backward in order for a ground to push you, the tires and a car forward, or vice versa. If the car needs to brake to slow down, then that force of friction has to have that impact backward on a car in order to slow down. If that traction, that contact does not exist, that means you are sliding through, you are cruising through, hydroplaning through without the chance to stop, and obviously that will lead in a dangerous driving and an accident. One safety feature found in many cars is an anti-lock braking system. However, let's talk about how the brakes work. So the pistons squeeze the brake pads against the rotor. Braking harder increases the magnitude of normal force, and remember that force of friction depends on a coefficient of friction times normal force. So force of friction is increasing when you press brakes. As a rotor is attached to a wheel, that means that rotor is going to force wheels to slow down. One problem with the disc brakes on a car is that brakes can stop the wheel from turning a lot faster than a friction from the road can stop the car from moving. So that means that that wheel will be locked, as we say, is not rolling at the same pace as a car is moving. So as you know, between the tires and a road has to be a grip. So static force of friction has to apply. If car is moving faster than wheel is rolling, that means that tires are skidding. Skidding the tires, sliding through the road will make that static force of friction turn into a kinetic force of friction that makes stopping, braking dangerous. So what does anti-lock braking system do? It does monitor that speed of rolling of wheels and speed of moving the cars. If those two speeds are not comparable, that means the computer will send a signal to the braking pad to automatically and rapidly release. So by rapidly releasing, it will come back from skidding into a rolling again. So that will make that brake or slowing down the car safer. Another problem that ABS system resolved is different force of friction between the front wheels and back wheels. So we know that the front wheels will have a bigger normal force, bigger weight, because the engine is pretty much on the front of the car. So that as a result, the force of friction on front tires will be bigger than force of friction on the back tires. As the force of friction increases and the force to stop the car will increase, that means that back tires might not really be able to stop the car as the front tires. So that attempt to stop a car with a force of friction that is bigger than what actually is designed, that will cause the tires to burn or to burn rubber. You have seen it like a smoke coming from the tires. That is even more dangerous because, well, the tires will burn rubber, the smoke will come from the tire, then it's going to slide off the road, and that is going to change the friction into a kinetic force of friction, which you know the coefficient of kinetic friction is smaller than static force of friction. There's another point that I want to make. While the wheel is rolling, all the points in the wheel will move at the same rate relative to the car, relative to a point of reference, which is car. However, relative to a point of reference that is a road, those points in the wheel will move at a different rate. So the point at the bottom, at the contact with the road, is not moving, so speed is 0. And the point in the middle of the wheel is moving at a certain speed, which is the speed of the car. And the point on the top of the wheel is moving at twice of the speed of the car. So the ABS system will monitor those points. As a result, if it detects that the wheel is closer to complete stop, that changing from 0 to V to 2V is already not maintained, that then the computer will send the signal to the braking pads to release rapidly and automatically that braking to make sure that static force of friction is maintained. This diagram shows the braking distance with and without ABS system. So with and without skidding. And if you take a look at the speed of the car will make a huge difference. So take a look. When the faster the car is moving, the bigger the difference is with or without an ABS system. Let's look at the physics of car brakes, ABS system practice. A car is traveling at 30 meters per second along the horizontal road. The coefficient of frictions are, coefficient of static friction is 0.50, coefficient of kinetic friction is 0.40. What is the braking distance? Delta dA with ABS and delta dB without. So what is given? Coefficient of static friction 0.50, kinetic friction is 0.40. In V initial is 30 meters per second. V final is 0, has to come to complete stop. Delta dA and delta dB are required. Let's draw a free body diagram. Force of gravity and normal force, and let's label the positive direction are forward and up. On a y-axis, we have first Newton's law. F net is 0, so that means Fn plus Fg is equal to 0. Just follow the positive direction. Fn minus Fg is 0, so move the Fg to another side of the equation. Fn is equal to Fg. Now we can calculate the force of friction, which is a coefficient of friction times Fn, but Fn is equal to Fg, and Fg is equal to mg, so that means friction force is equal to mu F mg. On the x-axis, we have accelerated motion, so the only force is force of friction. So here we can follow the positive direction as well. Force of friction is negative, and we always label the acceleration as positive, but you'll see that it is going to come up as a negative value. So force of friction we already calculated force of friction here, which is force of friction is equal mu F mg. So now minus force of friction is equal to ma. We replace the force of friction with mu F mg. So that means minus mu F mg is equal to ma. M and m cancel. So what is left? We can solve for a is equal mu F g. Now, with ABS, acceleration is static force of friction. As we mentioned, the whole role of ABS is to keep the wheel rolling, to keep the contact between tires and the road to be static. So static force of friction has to apply. So if you see that acceleration is equal to minus 4.9 meter per second square, and without ABS is a kinetic friction because it's skidding, so it is minus 3.92 meter per second. So where those numbers came from again is mu s is 0.5 times 9.8 is minus 4.9, and 0.4 times 9.8, it gives you 3.92, and with a minus in front, it's minus 3.92. Now, since that we do have acceleration, we can calculate displacement using that common formula from kinematics, V final minus V initial divided by 2A. So V final is 0, V initial is 30 meter per second, all squared, divided by 2 times minus 4.9 meter per second square. And the answer here is 91.8. Let's do other one without ABS. So now with a kinetic friction instead of static friction. So the same thing is 0 minus 30 meter per second all in the square divided by 2 times minus 3.92 meter per second square. And the answer here is a 114.8 meter. If you see, there's a big difference on a braking distance. So when the car comes into complete stop, 91.8 with ABS and 114.8 without ABS. It's a huge difference. So it is much, much safer with ABS when we are braking. Electronic stability control is another feature to increase safety in a vehicle. The sensor of the electronic stability control is usually located in the center of the car. The purpose of this sensor is to detect if the car is tilting too much while making a sharp turn. To prevent both of this situation, electronic stability control can activate one or more brakes using the anti-lock braking system to adjust the speed so the car cannot fly off the road and goes out of control. And obviously that is a moderated control. So obviously the car, if you don't control it, will fly off the road. Electronic stability control cannot substitute a good driver. Be careful. You have to drive safe. However, those are added features for safety, but that doesn't mean that it will protect you from uncareful, unsafe driving. Crash testing is one of the most important tests done by a manufacturer before it put the car on the road or put the car on sale. One of the most important tools used in a crash test is a crash test dummy. Crash test dummy is designed to accurately simulate what will happen to a person during the accident. So to collect data on a car crash, a dummy has sensors, and there are three different kinds of sensors to collect those data during the test crash. Those sensors will measure two types of data: acceleration in the different parts like head and torso, and a compression on a chest from a seatbelt during the crash. So those data will help engineers to determine the nature and severity of injuries and how to protect from it. As we talk about a sensor that measure the compression on a chest during the crash from the seatbelt, a safety feature to help in this situation is a load limiter. Load limiter releases some of the belt if the tremendous force starts to pull on it, obviously during the accident because of inertia. When a person in an accident pushes forward on a seat belt with a large force, the stitching breaks and a greater length of the belt become available. So this decrease of force will save the person during the accident, or is going to cause the minimum possible damage during the crash because of the force of inertia. Car body is designed in that way the front of the car should be able to crumble during the accident. This crashing action increases the time it takes for a car to come to a complete stop during the collision. More about this you're going to learn in grade 12 about collision. By increasing the time interval during the crash, the acceleration of the people within a car and the force acting on those people are significantly reduced. There's a lot of plastic used when we build a car. There are two main purposes of using a plastic during the collision. First, they do not interfere with the crumble zone. So the car in front has to crumble in order to reduce that impact on the car, in order to reduce that damage that will happen to the people in the car because of the change in the velocity. So because of the acceleration, and acceleration is related to a force. Second one, the light weight of the plastic keep the mass of the car low. So the smaller the mass of the car, faster will come to a complete stop. More about this you're going to learn when in grade 12 in a unit of momentum and collision. Another safety feature that is added on a car is airbags. Airbags are deployed during the car accident to prevent the people inside of the car from hitting hard surface like dashboard or steering wheel. So the nitrogen gas rushes inside of the nylon airbag that is folded in a steering wheel or in a dashboard or a sideway in order actually to serve as a cushion, to serve as a pillow to protect from hard hit. When an accident happens, a sensor that detected collision causes that a chemical reaction to happen between sodium iodide and potassium nitride to produce nitrogen gas, which rushes and inflates an airbag. The reaction happens so fast that airbag is pushed out at over 300 kilometers per hour. So sometimes inflating that airbag may cause injury in children. That's why it is not a smart idea and is not safe. It is not allowed for kids under 12 years old to sit on a passenger front seat. So as I said, if the person is sitting too close to an airbag and that rapidly inflating, that can cause a serious injury to head or arms. For that reason, children under 12 years old should never sit on a passenger seat. Instead, they can sit on a back seat that are more protected. And that's about it. This is the section 4.4, forces applied to automotive technology. I hope you like it.